Hello friends, I am Dr. Rao. I hope you guys are doing well. Welcome to my YouTube channel Mathematics by Dr. N. Rao. Today I am going to record another important lecture based on the De Moivre's theorem. Here I am going to discuss the important questions based on the De Moivre's theorem. Okay, so now I start. The questions are very simple. Okay, solutions. Prove that 1 plus sine theta plus iota cos theta equals to plus iota cos to the theta to the whole power n plus 1 plus sine theta minus iota cos theta to the whole power n equals to this. So I will take first left hand side to prove it for right hand side. So what about the left hand side? It is 1 plus sine theta and plus iota cos theta to the whole power n, and then plus 1 plus sine theta minus iota cos theta to the whole power n. Come on, what about this? Okay, it is your left hand side. We need to prove it equals to right hand side. Oh, and see, the answer is looking quite difficult, but it will come in very simple steps. Okay, by using the basics of the mathematics, very basic of the mathematics. Okay, so don't be stressed. So come on, 1 plus sine theta plus iota cos theta to the whole power n. Now our target is to write this. How will we simplify it? Now it is the questions. Okay, one of the important thing is that it is right in the form of sine and cos. The imaginary part here in terms of cos. So if you see in terms of De Moivre's theorem, so it will apply for cos theta plus iota sine theta to the whole power n, means your real part should be cos, your imaginary part should be sine. Okay, but here it is reversed. Okay, now we will try to convert in the first step sine is a cos and cos is a sine. So I will write here 1 plus, in terms of cos, sine will be written as cos pi by 2 minus theta, and then plus iota sine pi by 2 minus theta in place of sine theta to the whole power n, right? And plus similarly we will do in this part 1 plus cos pi by 2 minus, we are doing the very basic mathematics, minus iota sine pi by 2 and minus theta, right? Okay, to the whole power n. Okay, now come on, what about this? Just see here, you will see 1 plus cos, 1 and cos. So whenever you see 1 and cos, then try to apply the formula of cos theta so that 1 is cancelled out. Every time you need to this. Okay, क्योंकि हमें पता है कि 1 और cos का बहुत बेर होता है, तो ये दोनों साथ नहीं चलते कभी भी, है ना? So come on, apply the formula here. So we will apply here. Okay, 2 cos square pi by 2 minus theta minus 1 in place of this, right? 2 cos square, it is your theta. Okay, so 1 by 2 will also be there. Okay, now plus iota in place of sine, you can write it sine 1 by 2 pi by 2 minus theta, and cos 1 by 2 pi by 2 minus theta, right? Similarly to the whole power n. We will do for the next one 1 plus, we will write here 2 cos square 1 by 2 pi by 2 minus theta, and it is minus 1, and then plus minus iota 2 sine 1 by 2 pi by 2 minus theta cos 1 by 2 pi by 2 minus theta, right? We have applied here the simple steps. Okay, that is one. I will say if I need to apply the formula for sine theta, so I can say I can write it sine 2 theta by 2, right? So I will write here the formula for sine 2 theta. So which is 2 sine theta by 2 and cos theta by 2. So the value of theta is here pi by 2 minus theta. Okay. Similarly for cos theta, I can say cos theta. So it is 2 cos square theta by 2 minus 1. So my theta is here pi by 2 minus theta. That's why I have used here 1 by 2 pi by 2 minus theta. So now come on, what about the next step on simplification? You will see this one is cancelled out, this one is cancelled out. What about the remaining number of terms? So you will see 2 cos square multiply 1 by 2 inside, it is pi by 4 minus theta by 2, right? So plus 2 times iota sine pi by 4 minus theta by 2 and cos pi by 4 minus theta by 2, right? Very simple steps. Okay. Similarly, in the next step I will write 2 cos square pi by 4 minus theta by 2 and minus 2 iota sine pi by 4 minus theta by 2 and cos pi by 4 minus theta by 2, okay, to the whole power n. So if we take 2 common outside, so it will be 2 to the power n in both the terms, and you can take cos pi by 4 minus theta by 2 from both the terms. So it will come here cos to the power n pi by 4 minus theta by 2. And remember, these two factors are the part of both the factors. So you will write here cos pi by 4 minus theta by 2, right, from this term. Then similarly plus iota sine pi by 4 minus theta by 2. Okay, this one from this one. Okay, right. And then plus, similarly you will left here cos pi by 4 minus theta by 2, right, and minus iota sine pi by 4 minus theta by 2, okay, to the whole power n. Come on. Now again apply the De Moivre's theorem. You will write here 2 to the power n cos n pi by 4. So simple mathematics is going here. Okay, apply the De Moivre's theorem here. So we will write cos n times n, not it is n times pi by 4 minus theta by 2, okay, and then plus iota sine n, right, iota sine n pi by 4 minus theta by 2, then cos n pi by 4 minus theta by 2, and then minus iota sine n pi by 4 minus theta by 2, right? So these two terms will be cancelled out. What about the remaining terms? So you 2 to the power n cos n pi by 4 minus theta by 2, okay, and it is 2 times. You will see 2 cos n pi by 4 minus theta by 2, okay. So you will see 2, there is a power of 2 to the power n, 2 to the power n, so you can write it in a collective form as 2 to the power n plus 1, and it is cos to the power n pi by 4 minus theta by 2, and this term, okay, cos n pi by 4 minus theta by 2. Hence proved. So the solution is quite easy. Okay, just we have used the simple steps here. Okay, next we prove the similar part. Okay, the similar question is going there, but there is a in terms of denominator. So now I start the solution, and it is again required the simple manipulations. Okay, I will take the left hand side first. So what about the left hand side? 1 plus sine theta plus iota cos theta to the whole power n. Okay, wait, What about in the denominator? 1 plus sine theta minus iota cos theta. Come on. So, come on. I think I can write in place of 1 here cos square theta and then plus sine square theta and then plus iota cos theta here to the whole power n. And then we can say in the denominator 1 plus sine theta and minus iota cos theta to the whole power n. Okay, it's very easy. Okay, so I can write here in place of this term I can write it as sine theta plus iota cos theta, right? It is a manipulation here to make the calculation simple. Sine theta and minus iota cos theta. Check it out, come on. When a minus b, a plus b, so you can write here sine square theta minus iota square cos square theta. The value of iota square is minus 1, so we will get the same. Okay, so and it is plus iota cos theta to the whole power n. Now in the denominator we can write 1 plus sine theta and minus iota cos theta to the whole power n. Okay, so I think something is missing here. Okay, let me check it out. Okay, come on, sine theta is missing here. Okay, if you see 1 plus, so in place of 1 I have written cos square theta plus sine square theta. So in where is the sine theta? So I'm writing here plus sine theta. It is going inside the bracket. Okay, so here plus sine theta, it is going inside the bracket. Okay, so you will see, what about this sine theta, right, plus iota cos theta and sine theta minus iota cos theta. What about this? It is plus sine theta and plus iota cos theta. So you will see this, right, to the whole power n, and whole divided by 1 plus sine theta and minus iota cos theta to the whole power n. So come on, you will see, take sine theta plus iota cos theta as a common. So you will see sine theta plus iota cos theta to the whole power n is outside. So remaining is here 1. In place of this you will see here 1 plus sine theta and minus iota cos theta to the whole power n, and in the denominator you will receive the same terms, 1 plus sine theta minus iota cos theta to the whole power n, which will be cancelled out. Okay, so you will get here sine theta plus iota cos theta to the whole power n, and which is not the cis form, means here the imaginary part is the cos theta and real part is the sine theta. So we will try to convert it into the cis form. So we can write it cos pi by 2 minus theta and plus iota sine pi by 2 minus theta to the whole power n. Apply the Moivre'S theorem, we will write cos n pi by 2 minus theta and then plus iota sine n pi by 2 minus theta. Okay, I think it is proved. Now what was, yeah, it was the proof. Okay, it was the proof, hence proved. So you can say hence proved. So guys, see you in the next video lecture with some contents and some important examples. So keep in touch. Thank you for watching the videos.